Hey vintage audio fans, I have an old CD player from Akai. This is a CD A30 single disc. This unit would be, I'm going to say, mid-80s. Let's see if it works. Here I have an old Akai CD player. This is a CD A30. Know nothing about it. It opens. Will it play? Well, I'll try a CDR. I doubt whether it's going to read a CDR. This is pretty old. I don't know what year this is. Let's see if we can look it up. But let's just see. Oh, it says it's got 18 tracks on this thing. Is it actually going to work? Yeah. It just kind of spun up and spit the disc out. But it did read that there was 18 tracks on the disc. Let's see what happens with a stamped disc. This one should say 99 plus tracks. And it says there's nothing on this disc. I have a feeling it's not even going to play. Interesting. This might be an interesting one to take a look at. I know I've looked at a few of these old dinosaurs in the past, and this is certainly up there with as far as dinosaurs go. When was this thing made? Does it say? It's made in Japan, but I don't see a date on this unit at all. But this thing's got to be early 1980s. So let's pop this one apart and see whether it can be made to work. Don't get upset the way I'm handling this unit. It's mine. First thing we notice in this mechanism is the light source for the LCD is an incandescent bulb. Isn't that kind of neat? A lot of old ones did that. This is what I'm using for a pickup. Well, we'll see what happens when I put a disc in. So the disc spins. Now it's going to read 99 tracks. Will it play them? Turn on the sound system. Little background on this unit. I got this unit given to me a couple of years ago, and it's been sitting in storage where it's been sitting very cold. It's about 8 degrees in the storage unit right now. It's like 13 degrees in the shop, and I just went and had dinner, and it's sitting for an hour or so warming up. So that might explain why it's working now and it wasn't working before. It was just too cold. Okay, now this thing's deciding it wants to play. It certainly didn't play before. In fact, when I tried playing the CDR, it actually threw the disc out while it was still spinning. But that might just be a characteristic of such an old system, because this was made long before we had these recordable discs. But let's just try it again. Seems to be reading a regular CD, although it didn't read the regular CD before. And now it's reading this disc. That's weird. Now, it has been sitting plugged in for a little while, because when I first started on this, I got called for dinner, and I went in and had dinner. And I came out and took it apart, and it seems to be working. We'll check the focus and everything. We'll take a look at the eye pattern on this unit, because this one's a fully manual adjustable unit, and we'll just see whether there's any improvements that we can make. This has got a lot of analog circuits in this here. Look at the analog filters on this for the sound capacitors here. These are the analog filters to take out the sampling noise that would be noticeable on a lot of these old machines. They were not oversampled. So this was sampled at 44.1. Later systems, they went to an oversampled DA converter. so that you move the sample noise higher and higher up into the ultrasonic spectrum where you wouldn't hear them. But the early players, they all had that 44.1 kilohertz sample frequency that was present in the output, so they had to use a circuit to eliminate it, and they did it with these tuned notch filter basically that would notch out the 44.1 kilohertz signal that would be present from the clock for the DA converter. So our test point is the EFM and ground. Our adjustment points will be the focus offset and I believe the focus gain and the tracking gain right down here. Let's take a look at that eye pattern. That is a beautiful eye pattern. Look at that. That is so clear. Wow. A little bit of jitter, but that's actually what you want to see. It's amazing that this thing is as clear as it is. Now, why it didn't work when I first fired it up, well, maybe it's because it's been sitting cold and it warmed up a bit. I'm just adjusting the focus offset here. See, ideally we want to make the eye pattern as clear as possible here. If I shift this up a bit so we can see it a little away from the baseline, we just want to make that pattern as clear as possible. We want that diamond, that nice clear diamond. With the minimum amount of jitter. So that's the focus offset. Next one will be the focus gain. Here's the focus gain control. Oops. Now if you have too much focus gain, you'll hear it. If I shut the sound down, if I turn up the focus gain, listen. Hear it squeaking? So ideally what we want is we want to minimize the jitter without making it really loud. So we go too low, we're going to get too much jitter, you see? We try to minimize that jitter. And it's right at the sweet spot where we minimize the jitter and keep our eye pattern clear. Next one is the tracking gain. And I can actually unplug different things on here. Which one did I just take out? I just took out the focus. Killed the focus servo. This is the tracking servo I've now killed. Now I can adjust the tracking gain. This is the tracking gain I'm adjusting now. You notice it. And we're mistracking. Again, it all can be seen on that eye pattern. This is the tracking error test point I'm looking at now. We want to minimize. See, if I adjust the tracking error or tracking gain, you can see the tracking is jumping up and down. We want to try to minimize that. Too low, And you're going to see it bobbing up and down. We try to minimize that. That's done with the tracking error control. And if I move over, that's the TE test point. I'll show you that on the screen here in a minute. Focus error test point. We're going to adjust the focus gain. Again, to try to minimize that. Now again, if I go too high, we'll start to see little spikes there. Ideally, we want to try and keep the waveform relatively flat. This can all be seen in the eye pattern though. If you're looking at the eye pattern, if you're out of whack, it will affect the eye pattern. Ultimately, this is your friend, the eye pattern. That's what you want to maximize with those three adjustments. Now keep in mind that I'm using a CDR. A CDR does have a wobble to the actual track itself. That's the way that CDRs operate. If you were to magnify the actual spiral track that's recorded on the disc, it doesn't, like, it's not a smooth spiral groove that starts at the center and works its way out. This is back to a stamped disc now. On a CDR, the actual groove that's, or I shouldn't say, I call it a groove. It's not a groove, it's a track. But it's the equivalent to a groove on a standard phonograph record. On a vinyl record, there's a physical groove that's cut into the vinyl that the stylus tracks. On a CD, it's an optical track that starts at the center and goes from the center to the outside. And on a CDR, what makes a CDR different from a stamped disc, the laser is just tracking pits and lands that are stamped into the disc. But on a recordable disc, there's actually a wobble, because when a disc is blank, the recording laser needs something to track while it's recording. Once a disc is recorded, yes, there's reflective pits and non-reflective lands, because how a CDR works is the laser punches holes in this dye layer, which then allows the laser on playback to reach the reflective surface and be reflected back. And where the dye is not burned, the opaque dye blocks the laser. That's where you get your on and off, or your in focus and out of focus pulses. Much like the silver disc, the pre-made stamp disc, which has actual pits that are molded into the plastic. But on a CDR, the drive making the recording needs something that it can track on. So the actual track has a slight wobble at a specific frequency. And the difference between the different types of discs, especially when it came to DVD plus R versus DVD dash R, it was a different frequency that they used. And that's how the drive was able to track it. On CDR, it's all the same, but there is a track that has a slight wobble, which you will see as more of this on a burned disc. That's why some of the earlier players had a real tough time trying to play CDRs. But if you have an old player that will play CDRs, it'll play pretty much anything. Because that was always an issue with these older players, is that they did not like CDR discs. Because one, they had lower reflectivity, and two, the wobble on the spiral groove or the spiral track was more difficult for the laser to track. I'm just looking for a different brand of discs. A disc here. I've got a couple different brands of CDR. I'm looking for my other one. Let's see how it plays. Oh, is it here? No. Looking for my other CDR because it's a different brand, and it is not a dark green like this one. It's a more of a silver disc. Okay, I got a different brand of disc. This one is a Staples special. It's a cheap disc with lots of scratches on it. So if this player can actually play this disc, we're doing okay. See, there's definitely a difference in the reflectivity. This one has a little higher contrast because it's a green. The older CDRs that were green and blue were much easier to be played back on older equipment. These ones here have lower contrast because they're a higher sensitivity disc, and they're typically a little bit harder to play back. But we'll see if this machine can play it. Now, remember, we'll take a look at the output here, because you'll definitely see a difference in the output from the laser. Let's take a look. It's playing fine, but there is definitely a difference in the output. I wonder if I can increase it or not. No, it's maximized. Yeah, it is maximized. Let's take a look at the scope so you can see the difference between the silver CDR and this one. So here is the silver CDR. So if we look at the scope, we will see that we have pretty much almost two divisions. Okay, almost two divisions. Let's change the disc. Okay, there's the difference. So the other one was almost two divisions, and this one's a little over. This one's like 2.5 divisions. If I go to the stamped disc, and as you can see, the stamped disc has even more signal. Let's skip to the next track. How do I do that? There we go. So if we want to take a look at this, let's just put something on here to mark the screen without marking the screen. I'm just looking for something to stick on the screen. Maybe I'll just put my finger on here. Okay, so here's where our stamp disc is. As you can see, a little bit less, substantially less. Still enough for playback. So we're right to here. Right? Quite the difference in the output. And then back to the silver CDR. So if you wonder why some older CD players won't play CDRs very well, that's the main reason, is the reflectivity. Now, as to why this one wouldn't play when I first plugged it in, good question, because it didn't play when I first plugged it in. But this thing has been sitting for a while in the cold, so it may be that it just wanted to warm up a bit. It's a little warmer here in the shop. I don't have the heat on in the shop here, but it's about 13 degrees in here now. And where this came from, it was being stored where the temperature is more like about 8. because it was stored in an unheated storage where I dragged it out. But it seems to be playing, and it seems to be playing fine now, which is good for a unit this old. That's actually very good. This CD player is actually working very well. I'm quite impressed with how this thing is performing. See how it handles being banged around. Seems to track up pretty good. One thing this old beast probably could use is lubrication of the optical pickup and transport. Let's close this. How do I get into this one? This actually should come apart. The clamp should come off this thing quite easy, I think. Could be wrong, but it should just lift off. Most of these do, they just pop out. Let's get to figure out how to do it. I think if I open the tray and I lift this up like that, comes off just like that. Okay, so now let's take a look at this transport and see how dry it is. That might have been one of the things too, was when it was cold, it was sticking. What moves this one back and forth? We want to move the sled. The sled motor plugs in over here. We can just use like 1 volt or 2 volts from a power supply, and we can move the sled out. There we go. That's 1.2 volts to move the sled from one extreme to another. So I'm going to move the sled all the way out as I want to put some lubrication on these posts. Rails are actually dry. That might have been one of the problems earlier, was when it was cold. Uses a standard, I was thinking maybe this one used a BSL motor, but it's just a standard DC motor here as the spindle motor, right? Your standard Mitsubishi maybe motor. I can't really see the logo on it from here. But it's a Sony pickup. It's a KSS 121 is the optical pickup on this one. And it's all metal. Unlike the more modern pickups, look at the laser on this. It's a Japanese Sony pickup, but it's all metal. We're going to lubricate these bearings here. So I wanted the transport all the way out so that I could get some grease onto the rails here to lubricate this thing and keep it good for many more years. So we're going to use some Molykote grease. I'm just going to put a little bit onto the rail here, and then we'll let the mechanism spread this around when I retract the laser. Now we don't want to put too much of this stuff on, because too much grease is worse than not enough. It'll attract dirt. We just want to get enough on here that when the optical pickup returns, it will provide a thin coating that will keep the bearings from sticking. So I'll reconnect the wire. Incidentally, there's another plug down here for the drawer motor on this. And this unit is made by Akai. They just happen to use a Sony pickup, which was one of the few companies that were making pickups back in the era of this. You basically had a Sony pickup or a Philips for a lot of these earlier players. Okay, when I turn on the power, plug the power in, the pickup should return. Probably close the drawer too. There we go. So that'll spread that lubricant around. This chuck has a magnet on it. So I want to make sure that that part is clean. But there's a magnet in here which is retracted down to this metal plate. That's what clamps the disc in place on this unit. So we'll open up the drawer again. If you want to remove the drawer completely on this, you lift up that tab there, but there'll be a switch here that also you'll have to remove, otherwise it could get bent. There's two leaf switches. One over here that indicates when the drawer is open, and one that indicates when the drawer is closed. And if either of these switches go bad, well, if this one goes bad, what will happen is the drawer will open and then it'll close again. And same with this one here. If this one here goes bad, the drawer will typically open again. We insert the 2 pins in the metal bracket, snap it in place, and the player spins up and starts playing. That's my amp that's cutting out there, by the way. If you hear the one channel sounding kind of crackly, that's my amp. Let's take a look at the display on this one, and then we'll put that 100 track disc in and see if we can search them all out. So this one has an LCD screen. It tells you your track number and index number is what it tells you. It doesn't tell you the time unless you actually push a button on here. If you press the display button, it'll tell you your track time and it'll tell you the total time. So as we go through to the next track, for example, total time now we're in 4 minutes on the disc. If I go to track 6, for example, individual time, we're at the 19-minute mark of the disc. And the counter stays at what you set it to. I believe this has got memory on it as well. So you can set an A and a B point for your repeat. I think it can also, if I stop it, I can program this unit to play tracks in random. Okay, track number. Okay, so if I select the track number, press memory, aha, track. See, I can program in multiple tracks in the order I want to play them. And then when I press play, it'll start by playing track 4. And then it'll skip to track 11. Track 17, track 3. It's actually fairly quick for a mechanical laser drive, like the going to track 20. This one might be a challenge. Oh, it got there. Just took it a while to get out to the edge of the disc. If we look at the display here, we're at the 76-minute mark of this disc. Now I have to remember, this thing was built in an era when 74 minutes was considered a maximum recording time for CDs, but of course with CDRs they started pushing the boundary and recording more out to the edge of the disc. And there were 74 and 80-minute CDRs available. The big difference between the two of them, this one being this is a 74? Yeah, this is a 74. This is an 80-minute that's playing in here, but this is a 74. And what they did to give a longer recording time, not only did they squeeze the tracks slightly closer together, but they allowed the spec to go out further to the edge. Whereas on the shorter disc there was a reserved area at the edge, called the lead out area, which would stop the recording, and it would tell the player, okay, you're at the end, stop. So they relaxed that space to allow the track to record more to the edge of the disc. There were a few other things they did, but that was the big one, was changing the lead out space on the disc to allow the pickup to go a little bit further out. Not a problem with the newer decks, but many of the older players just weren't designed to go that far. I forget how far we got on this. See where this song ends. We're at 79 minutes and 25 seconds now. I think I pushed this right almost to the absolute end of this disc when I recorded it. It's amazing that this player is actually playing this without complaining. So I went to 79 minutes and 50 seconds, it looks like. Yeah, 79 minutes and 50 seconds is where that recording went to. That's actually pretty good. And it played it all without any problem. As you can see here, the lead out is right on the very edge of the disc. Just going to do one more thing before we finish this off, because this is going a little bit long, I think, but for those of you that have stuck with me this long, let's put in a disc with 100 tracks on it. This display should only go up to 99. We'll see what it does. It should tell me that there's 99 tracks on here. If I stop it, 99 tracks. There actually is 100. Okay, track 99 is only at the 62-minute mark on this disc. Okay, track number 99, it should go to 100, but it'll still show 99, like all the other players that I've tried this disc on. The individual counter will go back to 0 when it gets to track 100. I think it's only a 30-second track for number 99. Yep. So it should be Sea Lions is number 100, which is this one here. If it's actually going to play it. It says, oh, it's showing up as Music Index 2. Interesting. There it is. Track 100 is playing. It's Sea Lions. Showing us music track 99, index track 02. Because it's only 53 minutes and 25 seconds. It says total running time 53:25. Oh, that's also going to have the 2-second gap between each one. So there's only 53 minutes on the disc, but 63 minutes of total time because of the 2-second between each track. There's 2-second gap, which is counted as part of the running time. So it did play all 100 tracks. It just took it a few seconds to get to track number 99. But this one's working. Excellent. Another old vintage CD player from my collection that works. Yes, this one was given to me as well. All right, that's it. This one's working. Thanks for watching. We'll catch you in the next one. Bye.